All right. So I like to let the class decide how aggressive I get with these emails. This email will go out to anyone who hasn't filled out their course evals. How aggressive should I get? Probably not too much this early, but course evals are open. Please fill out your course evals. Please take the time to fill out your course evaluation. Feedback is very important for the continual improvement of our courses. You can also improve your grade and maybe even get a cookie. Oh my God, why are there so many buttons? Don't design things like this, please. I want to insert a link. It's going to be one of these. Link. Oh my God. Oh, fuck off. Damn it, I got to rewrite that. I forgot what I wrote. And it's to smart evals. What? The please. Okay. Please. There's not even spell check around here? Do I have to click the spell check button? Ugh. And I assume that's still the right link, right? It's got to be. Okay, look good? Nobody has suggestions for it? Shipping it. Oh, now they're not going to fill it out. Damn it. But we're at, how do we get back there? So you probably heard this a million times by now. You're in a 300 level class, but I can't see anything about your evals until after grades are due, and even then it's fully anonymous. You don't have to worry about any repercussions about your grade. This is all I get to see is the response rates. That's all I get. And I click what you just saw. I can send an email, and the system will send that email to students who haven't filled out their evals or not. So I can't use that as a way to figure out who filled out their evals and who hasn't, but the system will send that email just to the people who haven't. So I get no information except this response rate, which just went up by 3%. Yay, go us. And you can tell in 116, I decided to say, screw it, I'm not even doing an incentive in 116. And with no incentive, this is what the response rates look like. Without an incentive, usually it gets to like 20%, and that's it. It's weird that we have to bribe students to do this, but that's what it is. And this semester I just said, screw it, you know what, I'll just go without their feedback in 116. We got to change the whole course anyway, so it's going to be a wholesale, not to get too far down this path, but we're switching the course to Java. I got to change everything anyway, so their feedback won't really apply to next semester. In 312, your feedback will apply to next semester. I'll read your feedback. I'll make changes to the course based on it. So I want your feedback still in 312. So don't be shocked that these numbers stay low whenever I pull this up during lecture. Okay, but let's get on to some stuff. We got a good bit of stuff to talk about today. We got to clean up some slides that we didn't finish. And this whole week, I got a bunch of stuff I want to talk about this week. So as a roadmap this week, today I want to finish up what we would have done Friday. I got to finish up these slides. Oh, let me scroll here. We're pretty far towards the end of this. I want to finish up these slides. I added text. I don't want text there. I want to finish up these slides, talk about what certificates are, and then show you how to finish the last objective of the homework, objective 5 of the homework. For those of you who wanted to get this material on Friday, I made that Piazza post and linked to last semester's video covering pretty much the same content. But let's do that so we have it officially in this semester. And then the rest of the week, I want to take a project. I'll just find some project. It'll probably be, I don't know, the CSE 312 course website by default, if I don't think it's something more fun by then, and deploy it to the world with DigitalOcean, nginx. We'll get a domain name. We'll get a cert for HTTPS. We'll do the whole thing of, okay, I have this project. How do I deploy it to the world? Which, of course, is what you have to do with your project this semester. So showing you that whole process of how to go from the project that you have to deploying that to the world at a domain name. So that's Wednesday and Friday of the rest of this week. So that's our roadmap for the rest of the semester. And then, of course, next week it starts project presentations. So I'll bow out on Friday, and then we're watching presentations for the rest of the time. So if anybody has questions about the rest of 312, get them out there so we can address it. Well, we still have some lectures left. Anybody have questions right now? No, we don't. Yeah, I just said that. That's what we're doing right now. I got to wrap up these slides so we know what a cert is, and then we're going to install a self-signed cert using nginx. So the demo of the second half of today's lecture is going to be all about what to do, how to finish that. So today's the last day of lecture content, or not of lecture content, of homework content. Then the next 2 days are project content. The WebSocket connection fails for homework 4 if I use HTTPS. Any suggestions? I have a few suggestions. One, you have to make sure you forward the right headers. That'll be part of the demo later today. And 2, you have to switch the front-end HTML to say WSS instead of WS when you create the WebSocket connection. Once you do those 2 things, you should be good. Should be good to go. All right. So it's been a while, but we talked about all these security things. Encryption, we have this symmetric keys, which we just use to sign a partial secret to share a symmetric key, and then we can verify that the server did send that part of their key because they signed it with their private encryption key. So then we continued with the handshake knowing we were talking to the server. But there's a big problem with that, is there's a certain attack, a man-in-the-middle attack, which can render all that useless. So we have this public key encryption. Server sends public key over and signs with their private key and all that. But when the server sends us their public key, how do we know that we actually got their public key? So the man-in-the-middle attack, as the name implies, there's somebody in the middle of the server and the client who intercepts all the traffic, and you say, hey, let's start talking HTTPS, and then instead of forwarding that message to the server, or does send the message to the server and gets that message, but then sends the public key of their own, I worded that weird, sends their own public key instead of the server's and says, oh yeah, I'm that server for sure. Here's my public key, which they have the private key for that. And then when you start doing this handshake, you're using the attacker's public key to verify the signature, which of course the attacker signed because they have their private key. And then you think you're talking to the server, but you're actually talking to an attacker. And then there's no sense of encryption. They're masquerading as the server because when we asked for their public key, we got the attacker's public key. This is scary. This is pretty scary. And we have a solution. I think our last solution, our last security topic, is certificate authorities. Yeah.
So the attacker pretends
The attacker pretends to be the server. So if you have a server deployed out there, the attacker's pretending to be you. And your clients are connecting to them, thinking it's you.
So this
Scary.
is attacking the website, not a person.
I guess both, depending on how you look at it. But like if you go to MyUB and you're actually connecting to an attacker's site that looks like MyUB.
But you type in MyUB though, and they get in the middle.
Mm-hmm.
Oh, okay.
And they if they like are controlling part of the network, so this can actually happen on campus. Somebody brings in a router, plugs it in, and names their Wi-Fi, their SSID, UB secure.
Oh, so it's a fake internet connection.
It can't. I mean, there are other ways to do it, but that's one way. Like you're connecting to something you think is legit, but there's somebody in control of something along the line where they're intercepting your packets and just masquerading as the server. Our solution to this is certificate authorities. So a certificate authority, or CA, is going to sign those public keys. So instead of just sharing public keys out there, we don't actually do that, at least not connecting to a web server. We don't just get their public key. What instead we get is a certificate. That certificate contains their public key along with other information. The certificate authority that signed that CA, that signed that certificate, and these CAs, they'll sign the certificate to verify it. They'll sign it with their private key. And these CAs have the same problem, right? How do we know that we actually have their public keys, that they're legit? So the CAs, we have to get their public keys in a secure manner. Usually when we install our operating system or install our browsers, we'll get these secure, like known certificate authority public keys or certificate authority certificates. And these are called root certificates, root CAs or root certificate authorities. These are assumed to be trusted. Whenever it comes to cryptography and security out there on the internet, there always has to be some assumption of security. There has to be some secure communication, because we can go forever on this. Well, how do we know that there wasn't a man-in-the-middle attack when we got the root CA certificates and we got their public keys? Okay, well, however we got that information to verify that, how do we know that wasn't compromised? So the assumption with all of encryption on the internet is that we did, in fact, securely get these root CA public keys. It's an assumption of trust. We just assume that we got those in a verified way. So now a certificate is going to be the public key of the server, the domain name of the server, the certificate authority that signed the certificate, and a cryptographic signature of the hash of the certificate. So we're going to hash the certificate and then take a cryptographic signature. The CA takes their private key, signs that hash, which we can verify with the tools that we have. We have the certificate authority's public key. We use that to verify the signature that they actually did. They signed that hash, the certificate authority that we trust, signed that hash. And then we take the hash of the body of the certificate to make sure that's the correct hash. So if somebody wants to spoof one of these certificates, they have to break cryptography and hashing. They have to break both of them in order to spoof that signature. That's a tall order. That's a lot for an attacker to be able to pull off. So our assumption out there is that an attacker needs the CA's private key, and we trust that these certificate authorities are going to keep their private keys private. If a CA's private key is compromised, a lot of stuff blows up. So we assume that they keep their certificates, their private keys, private. Yeah.
So is a CA like a company doing a free internet service like Google?
Not free, but yeah. Yeah. They're certificate authorities, but yeah, they make money. They're for profit, for sure. If you have, which we'll see later this week, if you have a small amount of traffic, you're not a major site, you can get free certs, though, which I'll demo that. But once you have a certain amount of traffic, you're not getting free certs anymore. Like UB pays a lot of money for certs for all the traffic that UB has. So one thing with this is we usually don't get our certificates signed, our public keys signed by a root certificate authority. There's quite a few root CAs. You can see all your root CAs installed on your machine. It's a decently long list, but it's not incredibly long. It's, I don't know, dozens of root CAs. You usually don't have one of those root CAs sign your certificates. It's very common to instead have a key chain, where you have a chain of certificates that are signed by various CAs that lead to a root CA. So for example, I might have a CA, not a root CA, sign my certificate and say, I'm signing off on this certificate is valid. That CA will also have its own certificate to verify that signature of my certificate, and their certificate will be signed by a root CA. So the root CAs will sign certificates of a variety of CAs, and the CAs will sign our certificates, and the chain can be as long as we want it to be. I might have a root CA, sign for a CA, sign for a CA, et cetera, and that finally signs my certificate for my server. The chains can be quite long. Any chains that I see are usually just three. There's the root CA, a CA, and then the server, the domain itself. But as long as the chain ends with a root CA, we can use that to verify the CA, and we use the CA to verify the server. So very rarely do we have certificates that are signed by a root CA. If the key chain does not end with a root CA, I can't highlight just that bullet point apparently, it's called a self-signed certificate. It's a certificate that can't be verified. If your certificate can't be verified, what's even the point? There's no point to that. Because the whole point of a certificate is to avoid the man-in-the-middle attacks. If you can't verify the certificate with this assumption that, I got these root CA public keys and they're legit, I believe that they're legit. If you can't draw a line to those root CAs, there's no point. Like, just share your public key directly at that point. It's the same thing. It's a self-signed. You should not trust self-signed certs. Self-signed doesn't necessarily mean that they're actually signed by the domain themselves, by the servers themselves, but it means the key chain doesn't end in a trusted root CA. Yeah.
Is that the situation where a browser would say, like when you're trying to connect to a site, like, oh, hey, this site can't be trusted, and you click on details before you...
Yeah, that means their cert is bad for whatever reason. That can happen in a lot of ways. Certs expire. So a lot of times when I've seen it, the cert just expired. But if you ever get that caution, are you sure you want to proceed, all that stuff, something's up with the cert. If it's self-signed, I believe browsers don't even let you go there anymore. Well, they do, we'll see. But yeah, if something's up with the cert, you'll get all the security warnings. That lock will turn red and be unlocked. Like, your browser's going to yell at you these days. Because Google decided that everything needs to be encrypted. And when they run Chromium, which I'm not, my tone might have been off there. That's a good thing. I'm fine with it. But Google one day decided, hey, we're going to have all these warnings if your cert isn't valid. Because HTTP used to be used fairly recently, quite a lot out there on the internet. But then Google said, no, we're going to have our browser yell at you, yell at your users and scare the hell out of them if you're not encrypting absolutely everything. Even if it's public information. Like, this, aside from DMs, does Twitter need to be encrypted? It's public. It's all public. It's all out there. It doesn't really need to be encrypted. I'm fine with it being encrypted. It should be. But once Google made that decision, everybody said, well, shit, we don't want to scare our users. We don't want Google scaring our users, so let's get our certificates and get everything encrypted. I don't think I'm going to do the example because I want to get to how to actually use these things. So self-signed certificates, at the very least, I won't say don't, but be very cautious if you go to a site with a self-signed certificate and you get those security warnings. It can be fine, but just be aware that somebody could potentially be seeing your information. So if you're going to a site like that and you're not putting anything private out there, it's whatever. Use your own discretion. But you shouldn't be putting like credit cards in a site like that. Your credit card information, Any personal information shouldn't go there. Yeah.
If the site has a self-signed certificate, that means it's perfectly possible that an attacker is masquerading as...
Yeah, it means they're vulnerable at least to the man-in-the-middle attacks. Yeah, like we just talked about. So we will use self-signed certs for the homework, for educational and development purposes only. So for the homework, we're going to use a self-signed cert because your homework... So let me back up a second. Your certificate, when you go out there in the world and you want to get a certificate for your public key, you have to associate that with a domain name. So the certificate says, this is the public key for this domain name. So you would have to own a domain name to be able to get a certificate from a CA. No CA should or ever will give you a certificate for localhost. It doesn't make sense. It's not going to happen. You can't get a cert for localhost. You cannot get a valid certificate for localhost. So by definition, the way we're running our homework servers, it has to be self-signed because we can't get localhost, a certificate for localhost. Or else, I don't know, it'd just be weird to have a certificate for localhost. So for your projects, you'll go out there and get a domain name and actually get, I forgot. I forgot to put it on the project requirements, but you should have to get a cert, but I forgot to put it on there so you don't have to get a cert. I recommend that you do because it's super easy and you actually get the full experience of deploying a web app to the world that's secure, that doesn't give you all kinds of security warnings. So I recommend it, but accidentally not required. But anyway, you can get a CA signed cert for your project when you deploy that with a domain name. For the homework, self-signed cert. But don't actually use self-signed certs out there in the world. If you're deploying and actually getting users, just get yourself a cert. Yeah.
Who are you buying a domain name from, though?
There are lots of companies. Personally, I buy mine from Google domains, because they make it the easiest to manage my domains. But like Namecheap, GoDaddy. I hate that GoDaddy's the third one I thought of, but Bluehost. You could Google where to get a domain, and you'll get all those like 50 best places to get a domain in 2022. There's tons and tons of places to get them. I like Google just because it gives me a good dashboard and everything. And doesn't expect me to host there. It's a tangent, though. All right, so OpenSSL. If you've heard of OpenSSL, you probably heard about it in the context of Heartbleed. That's kind of an old attack, an old vulnerability. I heard there's a new one now, but I haven't looked into it yet, but I think there's a new one, OpenSSL. It is like the library to be able to do encryption. So it's constantly under attack by attackers, and sometimes they are unfortunately successful. Heartbleed was a buffer overflow error. If you're taking Alan's security class 365, I'm sure you've definitely heard of those. There was a buffer overflow error in OpenSSL, which was scary, and because so many sites were vulnerable to it, because everybody's using OpenSSL. We're also going to use OpenSSL. And this is one of those things where I'm talking about where SSL was renamed to TLS, but OpenSSL is still called OpenSSL, even though it does TLS now. They just didn't update the name, because why would they? Yeah. Well, just because they're not easy to create, just because they're easy to not create doesn't mean they don't exist out there. And when you're writing in C, it's kind of hard to avoid them. I don't know. Have you ever written a bug that you didn't mean to? But when the information you have that you're putting in the buffer is user supplied, you don't know how much information you're getting. Yeah, but if you forget to, then it overwrites your null termination. Your null's gone, and now buffer overflow. But yeah, you have to sanitize your input. You have to sanitize user input for sure. And that's usually how buffer overflow is happening. Take user input that you're not checking those bounds for, and then you're done. We're going to use this to generate keys and sign certs. So let's create a self-signed cert using OpenSSL. And I'm going to get this in my clipboard right now so I don't have to go back to my slides later because we're going to run that command. So OpenSSL, it's pre-installed if you're using Linux and Mac. If you're using Windows, there's an extra step for you because there always is if you're using Windows. But you can get this in the command line, run that, and that will generate your cert. You're going to be asked a lot of questions when you run this command. Most of those questions you can leave blank. It's extra information that you can have. But you need to answer country code. If you don't answer country code, for whatever reason, it just won't work. It needs your country code. So this command, there's a lot going on with this one. So let's go through this one at a time and see what's happening with this command. US. So they're all two-digit country codes. So US for the United States. Oh, no. US for your country code. So you're welcome to adjust these. I don't see why you would unless you're really exploring this space and want to learn more about it. If you just want to get through the homework, just cut and paste this thing and run it. But if you do want to change any of these things, let me go through what they all are. Rec. So OpenSSL, that's the program name. So I'm invoking OpenSSL. Rec says I want a certificate, and I want it in the standard X509 format. This is the format that we use on the web. This is going to give us the right format for websites. New key, RSA 4K. I'm creating a 4K key size using the RSA algorithm. I want my private key to be saved. Oh, I'm on the next slide. I want the private key to be saved in a file named private.key. I want the cert to be saved in a file named cert.pem, which these two would probably be the two that if you want to change anything, maybe you don't want those file names. I don't know. I don't know what you want to do. It's up to you. The cert will expire in 1 year. Did I not put SHA-256 in the slide bullet point? Use the SHA-256 hashing algorithm. And don't require a password to use the private key. No DES. So that's going to create your public certificate and your private key and save them as those two files that you named in the command. So at this point, we have a self-signed cert with a private key that we're responsible to keep private. Now, we have a few options at this point. This should be my last slide. We have a few options at this point. We could actually add this code directly, add this cert directly using our code and inject the certificate right into our code. To do that, you would get your TLS connection, look up the documentation for your language. In Python, you want to get the underlying socket from that socket server, and then wrap that in TLS and add references to your two files for your cert and your private key, and then the library will do the rest. We can do that. I tend to avoid that because I like the idea that I write my app. My app is the app. And then at a different layer, I mean, it is a different network layer anyway, at a different layer, I'm going to add TLS. So we're going to add TLS in a different layer using nginx as a reverse proxy server. And I'm going to try to demo this in the next 18 minutes and hope that it goes well. Yeah, with the, oh, I don't need to address that. It's already addressed. All right, so let's do this. Let's go to PyCharm. And I have, oh, not that one. We have server.py, which is, oh, wait, the server doesn't do anything. Here's how you would do it in the code, by the way. We're not doing it that way. But that's how you do it in the code. You link your certs but I have secure set to false. ITCP handler. I just want to make sure the server's sending something. Why am I using this server? Oh, because, yeah, I got my whole router and everything set up. Yeah, there's a lot going on with this one. All right, so for a second I thought it wasn't the one I was thinking of. But we have this set up as we usually do. How you got yours set up, we have the app and Mongo or MySQL running in 2 separate containers running through dockercompose. What we want to do is run something called nginx, which is another piece of software that we're going to use as a reverse proxy, meaning our users are going to connect to nginx, and nginx is going to forward that request to our server, get the response from our server, and then send that response to our users. So our users only ever connect to nginx, and nginx talks to our server. That's what we want to do. To set up nginx, you can install it. It's something you can install and run just like any other piece of software. But we're using Docker, so we're going to set it up using Docker. So what I want to do, and I have my cheat stuff here just in case I have to look. There will be a few things that I have to look at because I don't memorize all of this stuff. But I'm going to create a new Docker file for nginx. I'm just going to start with an nginx image. I run that Docker file, I got nginx installed. Docker's a wonderful thing. If you don't appreciate Docker yet after this class, I hope you will someday. But that's it. I can run this Docker file to build an image for nginx, and run nginx. As long as I have Docker running, which I'm not going to have Docker running, am I? Let's get Docker running before we get too far. I always forget to start Docker. But as long as Docker's running, I can just run nginx. I don't have to go through an install process and figure out how to install in my operating system. None of that. Just nginx. We will add to this Docker file just a little bit, not even all that much. But I don't even remember what the file's name, default.conf. But we need to set up some configuration for nginx. Default.conf, which is the file name that nginx is going to look for its configuration. And I'm going to set up nginx. Oh. I have to cheat already. Let me get at least some of this stuff down. So we're going to tell nginx, listen on port 80. And it's going to be a web server, it's going to listen for HTTP requests. And whenever I get a request on port 80, for any path, you can set this so it can route different paths to different locations. But I'm going to say for anything, for any request that I get, it's not called reverse proxy. I have to cheat already. Server, I do have that. Server name, server underscore name, localhost, location, proxy pass. You know what? I'm just going to cut and paste these because it'll be boring if I just sit here and stumble across the whole thing. And we want some lines here to what we want. That's a terrible lead-in. Anyway, so what this is saying is I'm going to listen on port 80. We're actually going to get to port 80 today and just have this listing. Usually nginx is going to be, or any reverse proxy or anything, it's going to listen on your top level ports, which is 80 and 443. 80 is the default port for HTTP. So if you make an HTTP request and don't specify the port, it's port 80. If you make an HTTPS request without specifying the port, it's port 443. So we've been using 8080 all semester, and that's usually one of the common development ports. But when we're ready to actually deploy set up this reverse proxy and have it talk to our app on port 8080, or in this case, 8000. So proxy pass means use this as a reverse proxy whenever you get a request on localhost for any path. Forward that request using HTTP to my app on port 8000. For this, we need to look at our Docker Compose file. So I'm setting up this nginx to work with Docker Compose. So that app is whatever I named my app right here. Just like connecting to MongoDB or MySQL, when connecting to your database, you have to specify the name that you gave it inside Docker Compose. It's the same thing here. We're having two different containers talk, which are both spun up using this Docker Compose file. So I have to use these as the host names. App, and then I used to have the app running on, mapping to local 8080, but inside the app, like actually in the server.py code, I'm listening on port 8000. So when I'm doing this, I have to make sure I'm using the port inside the container. Because with this, I'm going inside the container and talking to the port inside the container. So I can't use 8080 here. I'm making sure that I'm using 8000 or whatever you're listening on in your actual code inside the container. I'm using HTTP version 1.1. And then the next two, I'm forwarding two headers. If you're not using WebSockets, and this is my other thing that I kind of alluded to answering the WebSocket question. If you're not using WebSockets, you don't need these. But for whatever reason, this reverse proxy, nginx as a reverse proxy, by default won't forward these two headers that we need for WebSockets. When you have that 101 or the handshake and you respond with the 101, these two, upgrade and connection, which upgrade will be WebSockets and connection will be upgrade, these two headers won't be in the forwarded request that nginx forwards to your app. So if you're using WebSockets for Homework 4, you have to make sure you have these two headers just like you see here so you can actually get those headers. And there are other things. For example, the IP address will always be the IP address of nginx. So if you want the user's IP address, you would add an extra line here to forward that header of the actual IP address to get that on your server side. So with this, we have our Docker file, which we have to add a line here. We have to copy default conf into, and I'll definitely have to, let me see if I can remember. I think it's that. Default conf, etc. nginx conf d default conf. I'm going to copy and paste that just to make sure you don't have to watch me chase down a typo. And expose. I don't actually need those exposes, though. So I want to make sure I copy that configuration file into my container. So inside my container, the nginx running inside the container is going to use this configuration that I set up right here. Then we go to Docker Compose and add this service to Docker Compose. So build, I want to specify, so instead of specifying an image like I did here, I want to specify a Docker file. Before we just said dot, meaning look for a Docker file in this directory. Now we want to do a little bit different, dot nginx. So I want to say look for a Docker file in this directory, which is why I set up nginx in a separate directory to begin with, because I need my Docker files separated in the directory structure. And then we're going to map our ports that we need. Ports, and I'm going to set up this a little bit ahead of time, is 80 to 80. So my local port 80, I'm going to map to port 80 inside this container. So if I just type localhost with no port, it's going to go right to this container. And I'm also going to set up, this is what I mean by a little bit ahead of time. We're not using it yet, but 443. And if all goes well, which it never does, but we'll hope, Docker Compose up. And we'll see 3 containers being built here. And once they're built, I should be able to just go to localhost. Straight up localhost with no port. And hey, look at that. We got our site and everything's running through nginx, through 3 Docker containers and all kinds of stuff going on. In my, luckily I set this as an actual password field because my password manager decided to autofill that in for me. All right, so that's half the battle. That's cool and all. We're running our app through nginx, so we've verified that it's working. Like nginx is running, it's listening on port 80, it's forwarding port 80 local to port 80 inside the container. Everything's working great, but what we really wanted here was HTTPS. We also want listen 443 SSL, I think. So here's where, you know what, I used my clipboard. I did that on purpose and then didn't do it. I purposely grabbed this and put it in my clipboard, but then I copied something else, so I lost it anyway. So what I want to do is generate my self-signed cert. So let's get in our nginx directory, paste that line, and it's going to ask me 2-letter country code. This is the one that you have to answer. I forget why, but there's some reason why you have to. I'm going to answer that. And everything else, I'm just going to hold down enter. I don't have to answer any of these other questions. It's going to ask for all kinds of information. If you actually have or generating this for an organization, you'd want to answer this stuff. You know, if you were for some reason generating your own keys and then submitting your public key to be verified by a CA and then get your certificate, you know, you'd fill out all that information yourself. I'm in a virtual environment here. Oh, no, never mind. And now I can see that it created those 2 files. My certificate, which is going to look something like this, and my private key, don't hack me, but my private key, which should have about 4K characters. Right? That's not necessarily true, but where am I? 65 times 50, about that many characters, base 64 encoded. So whatever that ends up being, it should be 4K after you undo the base 64 encoding. But I have my cert and my private key. I have to do a couple things. I have to set up my configuration. There's 0% chance that I'll remember these. I'm not going to try. But SSL certificate key. So I'm going to grab these and say, here's where you can find my certificate and private key. I put this SSL on 443 to say any requests on this port should be encrypted using SSL, and then these 2 lines tell the server, hey, this is how you're actually going to do the encryption. And then the last step here, we're almost done already. I mean, that was quite a bit, but we're almost done. I have to make sure that I have that certificate and private key inside my container. So I need to copy these things inside my container. Cert.pem. Which we told nginx to look in etc nginx. So etc nginx, cert.pem, copy private.key. I should have known that one. Private.key to etc nginx. Bless you. Private.key. So we're going to copy those files into our container, so we make sure they're in our container, these 2 files. And then we're going to set our configuration to point to those files to handle SSL, which is actually going to be TLS. And then listen on port 443, and everything on port 443 will be encrypted using this cert and this private key. And everything else is the same. So from our app's perspective, whether request came over port 80 unencrypted or port 443 encrypted, by the time it gets to us, we're still just using HTTP. But everything that hits the actual internet is encrypted, because our nginx and our app, they're running on the same machine. I mean, it could be distributed, but they're going to be in the same data center. They're going to be over a trusted network where you're not so much concerned about attacks and eavesdropping and stuff. It's all going to be wired connections in the same building, typically. And when it's not, encrypt, send it to the other building, and then decrypt, and handle it that way. But internal, HTTP. So all the code you wrote that uses HTTP, you use all that code. We get to use all of that.
There's a typo in the Docker file.
Oh, thank you. You saved us there. So we're going to recreate this, rebuild the thing, and when we do, we should see that we can't visit our app using encryption. GoDaddy is the worst, by the way. That was the first hosting service I used just because they advertise like crazy, so they're the one I knew about. But yeah, like I said, I like Google Domains because they don't want me to use their hosting service as well. GoDaddy, not so much. Like you go to them, they want to keep control over your domain and have you host there. It was a pain in the ass to get my domain switched from GoDaddy to the next service after I realized GoDaddy wasn't really doing it for me. So localhost should still work, I hope. Oh, crap. No, we might not get there today. Share connection refused. Why isn't it? Wait, why isn't that showing up? Oh, it's thinking. The nginx container isn't running. Move arguments in proxy pass in the conf. Proxy pass. I don't have a semicolon there. Well, one semicolon. Sometimes that's what it takes. Oh, build faster, come on. We can get this. We got 1 minute left. We can get there, because there's one last thing I want to show, because it's not going to render our encrypted page. Okay, so we got that, and if I add HTTPS, it's going to say, we have a problem. Connection is not private. There's an issue with your cert, and there's no option to say, proceed anyway, I know what I'm doing. So there's one, my absolute favorite trick in browsers. If you actually, so I'm somewhere on this page, I'm making sure I have the page highlighted. You actually type out, this is unsafe. And it lets you do it anyway. It's like a secret backdoor. If you ever want to override that security thing, you literally type, this is unsafe on your keyboard, and it'll let you go ahead anyway. So once you type that, it's not going to be secure, but we can see that we have a cert. Our cert is here. We have all our stuff. It is, our communication is encrypted at this point. It's just not it's a self-signed cert, so we get all kinds of warnings. Yeah?
Is that with or without spaces?
Without spaces. Just this is unsafe, no spaces. All lowercase. And we did get there. Hey, we got encryption working. Have a great day. I'll see you all Wednesday.